Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on November 17th, 2025, about 2 days ago. It introduces a 3D-aware large language model that turns 3D understanding and editing into a single executable program, achieving state-of-the-art performance in grounded question answering, compositional generation, and fine-grained part editing. The paper is titled Part-X-MLLM, Part-Aware 3D Multimodal Large Language Model. And as we will see later, this unified program interface could really change how language models control complex 3D worlds. Also, the authors shared a GitHub repo for Part-X-MLLM. Right now, it mainly highlights the project description and abstract, with assets prepared for the work, and the rest of the page is still loading with an error, but the implementation and supporting materials are meant to be accessible there as it develops. Figure 1 visually summarizes what this model actually does with 3D content. The figure shows a band of colorful 3D scenes where individual parts like noses, arms, and tires are highlighted, which illustrates precise part grounding inside full objects. The left region demonstrates part grounding queries. The middle region illustrates detailed object and part captioning, and the right region shows part-based generation and editing, where outfits or object configurations change. Altogether, the montage conveys that a single language interface can understand, describe, and modify fine-grained 3D parts across many assets. Figure 2 explains how the system turns 3D inputs and language into a concrete editing plan. This whole diagram shows geometry flowing into a structure encoder, colors going into a semantic encoder, and text going through a tokenizer, which together feed the central planner. The left side with the mechanical owl illustrates how raw point clouds and appearance features become compact tokens. The upper right panel shows a generation head that turns planned part boxes into new 3D shapes. The lower right panel shows an editing head that applies add, delete, or modify commands to specific parts described in natural language. Figure 3 shows how one unified planning language supports several 3D tasks with the same kind of token program. The full diagram illustrates that a single breadstick basket scene flows through captioning, part-aware generation, grounded question answering, and auto-located editing, because all of them use bounding box tokens plus text. The left panel focuses on captioning a highlighted region inside the basket. The upper right panel shows those boxes driving new mesh generation. The middle strip demonstrates question answering, where the reply also points to the counted breadsticks. The bottom strip illustrates an edit command that replaces the red basket liner with the blue one while keeping the breadsticks unchanged. Table 1 shows how well different models predict 3D part bounding boxes. This table compares voxel recall, voxel intersection over union, and bounding box intersection over union, which measure how completely and how precisely parts are recovered in space. The proposed model reaches about 74% voxel recall, indicating it finds most of the true part volume. It achieves roughly 49% voxel intersection over union, showing clearly better volumetric accuracy than baselines. Its bounding box intersection over union is about 43%, so the planned boxes align more tightly with ground truth parts. Table 3 shows that this model is significantly better at understanding and answering questions about individual 3D parts. These scores compare several prior 3D language models against Part-X-MLLM on UniPart Bench. Sentence BERT similarity, which measures how close the generated answer is to a reference in meaning, jumps to about 79. Other metrics like SimCSE and BLEU1 also climb sharply, indicating both more accurate reasoning and richer wording about parts. Alright, wrapping up, the key idea is that 3D interaction becomes a single, executable language program, so the same model can describe, query, and precisely edit object parts. This unified planning layer, decoupled from geometry, hints at future game engines and design tools driven directly by natural language. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.